So we have some math modeling classwork questions. So like I said, I'm going to do these first two with you, and then you guys are going to do the next ones together. So for example, so number one, it says grain is stored in a tank made from a cylinder on the top and a cone on the bottom. So have you guys ever seen these silos? So basically like anything that's like dumping water or grain or whatever out is usually with a little funnel at the bottom. So we use funnels a lot in real life. So the vertex is pointing down. A picture is shown. The cone part of the tank has a height of 5 feet and a radius of 4 feet. Suppose the tank is nearly empty, but grain fills the entire cone portion and not the cylinder. Okay, so it's only in the cone. When the tank is opened, so the bottom we're opening up, grain's going to flow out at a rate of 0.5 cubic feet per second. Answer the following questions using the volume of the cone, which is volume equals 1/3 pi r squared h. Do you guys know that equation? Have you seen 1/3 pi r squared h? 1/3 area to the base times height. So how long will it take for the tank to completely empty? So we want to know exactly how much grain is in there. So we have a cone. We call this an inverted cone. So it's upside down. And its height is 5 feet. And its radius is 4 feet. And it's totally full, but it's not going into the cylinder at all. It's only in that cone part. So our volume is going to be 1/3 pi times 4 squared times h, which is 5. So we're going to find this number. So we're going to multiply everything out. So let's see, I get 16 times 5, which is 80. So I'm going to have 80 over 3 times pi. Okay, and you can find a decimal approximation if you want to. So I got around 83.776. Okay, what are my units? Feet cubed, right? So cubic feet, perfect. Okay, a lot of times in AP Calculus, you get a point just for writing the correct units. Isn't that exciting? Let's get in the habit of doing that. All right, so B. So it says write a proportion to relate the radius and height of the grain at any point in time. So here's what's happening. So the grain is leaving this cone, but we have another cone within it. So we have the cone of the receptacle, like the silo, but inside of it is a cone of grain. See what I'm saying? It's kind of weird. Yeah, what do you think?
Wait, the first question was asking how long
Oh, how long will it take for the empty? Yeah, so we didn't finish. So we found the volume, and it's flowing out at 0.5 cubic feet per second. So if we're taking this 83.776 and we're losing half a foot every single second, how do you think we figure out how many seconds it takes? Divide by 0.5, which is the same as multiplying by 2. Does that make sense? Do you guys understand why we're multiplying by 2? Because we're losing half of a cubic foot every second. So every 2 seconds, we're losing a whole cubic foot. So sometimes if you think about like chemistry and you set it up like this, it helps because there's 0.5 cubic feet every single second. Do you guys know what I'm doing here? You all took chemistry. We're good. All right, so cubic feet and cubic feet go away. And we're left with seconds, right? So that's what Sam was saying when she's saying, well, let's take our answer and let's divide by 0.05, or 0.5, I mean. So we do get 167.552 seconds. So write a proportion to relate the radius and height of the grain at any point in time. So like I was saying, there's like a cone of grain within the cone that's a receptacle. Do you guys remember similar triangles? That's what's created. You guys like always groan when it's like geometry stuff. You're fine, we got this. So we have our radius of the grain and our height of the grain. So that's an R and an H. But our original radius and height was 4 and 5, right? So 4 across here and a 5 for the height. So all we're going to do is we're going to say R over H is in the same ratio as 4 over 5. So for our grain, our radius of the grain divided by the height of the grain, which is changing. Do you guys see how it's going to get smaller and smaller and smaller? Well, it's in that same ratio of 4 to 5 because of similar triangles. with me? Yeah, you guys are like, triangles, oh my god. All right, so this relates the radius and the height of the grain at any point in time. Okay, so next question. What will be the height of the grain after 2 minutes? So after 2 minutes, that's the same as how many seconds? 120 seconds. So what were we saying? Well, it takes 167.552 seconds to drain out completely, so we're somewhere in the middle. So what do we want to do? Anybody have any ideas? So I want to know how quickly it's draining out. Do we write a proportion? We could. Okay, let's think about what happens in 120 seconds. So how much are we losing over that 120 seconds? How many cubic feet is gone? 60. How'd you get that, Hallie? Yeah, remember we're losing half of a cubic foot every single second. So after 120 seconds, we've lost 60 cubic feet. So how much grain is left? So we go back and we find that number we had, 167.552. And we subtract out that 60 cubic feet, right? So 107.552. Dang it, that's how long it took. Dang it. So I subtract out. I'm just really messing up, aren't I? I need all my numbers on the same page. So 83.776, is that what it was? Yeah. 83.776, and I'm subtracting out 60.000. So I'm left with 23.776 cubic feet. So I have a new volume of a new cone. And I know my volume is 1/3 pi r squared h. Right? So that volume is here. We have 23.776 equals 1/3 pi, and then we have this r squared h, and we're like, we can't have two variables to solve this. Okay, this is tricky. Some of you guys are going to totally get this. Some of you guys are going to have trouble with this. That's okay. I'm not going to test you on this. Don't worry. Maybe a bonus. Maybe I should put a bonus question. All right. So I need it to be a single variable. So I can't have both r and h. So how can I use something that I did before? No, close. It's using those numbers somehow. Let's cross multiply. Let's say 5r is equal to 4h. What if I wanted r by itself?
By 5 over.
Totally. What if I wanted h by itself? Yeah. So I think in this case, instead of doing r squared, I think I'm going to go ahead and solve for h. So I'm going to replace h with 5r over 4. It's always in that ratio. So I'm going to go to this equation, and I'm going to keep my r squared, but my h is going to be replaced with what it was equal to. So it was equal to 5r over 4. And then we solve this equation out. All right, you guys can solve this equation. I know you can. I'm going to give you a second to try solving it. You can do everything in decimals. You don't have to worry about that pi and the 1/3 and so on. So solve it out. All right, so let's get rid of the 1/3 by multiplying the 3 over. So when I did that, I got 71.327. So I left things nice and precise. I'll do this a lot, where that 23.776, I had that in my calculator because I did my 83 number that had lots of decimals. I subtracted out 60, and then I kept that number nice in my calculator, okay? So I multiplied by 3, and I got 71.327 equals pi r squared times 5r over 4. So we can do things, one at a time or all together. So let's divide by pi. So when I divide by pi, I got 22 something. Then I multiplied by 4 to get that denominator over, and I got 90.817. So at this point, I'm at this. So 90.817 is equal to r squared times 5r. So what's my next step? Divide by 5. So then I get r cubed equals 18.163. Now what? The cube root. So some of you guys might have trouble on your calculator finding the cube root. If so, you can always raise things. Like I did 18.163 and I didn't want to hunt for the square, cube root, so I raised it to 1/3. You can do that, or you could hit math, and under math, there is a cube root button. So when I did that, I got r is equal to 2.629. Okay, so it says, what will the height of the grain be after 2 minutes? We just found the radius, so we need one last step. So we found the radius of it. So if we go back here and we look at our way to relate our r and our h is equal to 5r over 4, right? So it's 5 times the 2.629 over 4. So I got 3.286 for my height, and that was in feet. Okay, tricky question. So part D says, we'll find the height of the grain when half of the original volume is gone. So you would go through that same process, only now for your volume, you wouldn't have 23.776, you would have half of the original volume. And you would do exactly the same thing. So we're going to skip that part. So I gave you a hint. The answer is not 2.5 feet, because a lot of people assume that if it was 5 feet originally, then halfway is going to be... Tell me what's wrong with that logic. Why is it not half of its volume at 2.5 height? Like, why wouldn't it not be 2.5 feet up there? Yeah, where's there more volume, at the top of the cone or at the bottom of the cone? At the top, right? So it's going to be a little bit more than half. Like, it's going to be higher than that. Does that make sense? So a lot of people make assumptions that you can't.